Solving rational functions, rational equations. You guys already know how to graph them, how to find all the important information. Now let's solve them, just like how we did with quadratics, okay? So you have this nice little foldable. There's basically three different types of rational functions that you're going to come across. But no matter what, a couple of key things that you need to kind of keep in mind when you're doing this, okay? You want to look for the common denominator, okay? Because rational functions, that's what they are. They are fractions. And so looking for the common denominator can be helpful. Multiply to get rid of the denominator. Y'all don't like fractions anyway, so why not get rid of it? You get rid of it by multiplying. And then, of course, you've got to check for extraneous solutions. Because no matter what, when you have a fraction, you can never divide by what number? Zero. So if you happen to solve it and you get a solution that gives you 0 in the denominator, that means it's not a solution and it's extraneous, okay? So just like with radical functions when we're solving them, you got to check for extraneous solutions with rational functions. So the first type that you're going to have, okay, the tip is you want to use cross products, okay? If you end up getting one rational expression equal to another rational expression, this is basically a proportion, okay? Long time ago, you have problems that were like x over 2 equals 3 over 7. How did you solve these?
I know how I times that too.
You would multiply like this, right? 7 times x equals 2 times 3, right?
Yes.
It hasn't changed just because now we got expressions, okay? So you do the exact same thing. That's what it means. Use cross products. So you multiply diagonally 8 times x minus 3 equals the other way, 3 times x plus 7. Okay, but the thing is they equal each other. They don't form another fraction. They equal each other, and then you just solve from there. Okay? What do I do with this 8 and the 3? Distribute. So that becomes 8x minus 24 equals 3x plus 21. And we just continue to solve for x, right? Subtract 3x from both sides. 8x minus 3x. And then what do I do to this 24? Add it. What's 21 plus 24? The last step. And what's 45 divided by 5? 9. Okay? Check for extraneous solutions. Now you can easily check by plugging in. Okay? So this would be 8 over, what's 9 plus 7?
16.
Equals 3. What's 9 minus 3? 6. 8 over 16 reduces to be, and 3 over 6 reduces to be. So since it works, that's your solution. Okay? And again, the only type, like you always make sure the left side equals the right side, but a kind of a shorter way as well to check, see if you plug 9 into your denominator, if you'll get 0. Okay? It's another quick way. Some of y'all don't like to check anyway. So let's do this one. Again, you cross multiply. So that's x times x minus 5 equals negative 3, 3 minus 7. Again, you distribute x times x. Negative 5 times x. Negative 3 times 3x. Negative 3 times negative 7. Ooh. This looks like a good old quadratic. A good old quadratic. So how do you solve a quadratic? Completing the square, factoring, or quadratic formula. Let's see if we can factor this first. It's the easiest way. Want to make sure everything's equal to 0, so I'm going to add 9x over and subtract 21. So when I add 9x, it becomes a 4x minus 21 equals 0. Are there two numbers that multiply to give me negative 21 that add to give me 4? 73? Positive 7, negative 3. Then I said both of those equal to 0. So x equals and x equals positive 3. Okay? Quick check. Negative 7 all over. What's negative 7 times 3? What's negative 21 minus 7? And about negative 3 over. What's negative 7 minus 5? 2 negatives make a. And what does 7 over 28 reduce down to be? And isn't this one 1/4 as well? So negative 7 works. Or you do it by just checking the denominator. What's 3 times 3? What's 9 minus 7? What's 3 minus 5? Negative 3 minus 3 minus 5, sorry. 2 negatives make a. So that works. They both work. But that's how you do it using cross products. You can only use cross products if you have one fraction equal to another fraction. One fraction equal to another fraction. Questions? The next type, multiplying by the lowest common denominator. Now this one, I can't use cross products because I have 2 terms on my left, 1 term on my right. Okay? But the skill here is to multiply by the lowest common denominator. What is the lowest common denominator here? X plus 7. So if you can figure out what the lowest common denominator is, you want to multiply every single term by that lowest common denominator. Every single term. Okay? Now, I'm going to show it for A, but I'm probably not going to show it for B because it's really tight to write. So if I multiply every single term by the lowest common denominator, what do you think happens with this first set, with those x plus 7s? They're going to cancel, so then I'm just left with x. But over here, I'm actually going to multiply that 3, or that negative 3, over to that x plus 7. And then what about on the right side? What happens? Cancels out, and I'm left with negative 1. By multiplying by the common denominator, I'm getting rid of the denominator. And now it's just an expression, maybe it's a linear equation or a quadratic equation that I can solve. Okay? What do I just say? Negative 3. So it's going to be negative 3x careful, don't make the mistake. X minus 3x is what?
Yeah, wait, yeah.
That's what I was worried about. When they're on the same side, you combine like terms. Okay? Some of y'all, it's not often, but it can happen. Some of you guys subtract that x to the negative 3x. They're on the same side. You don't do that. You just put them together. Keep going. What's negative 1 plus 21? And then x equals. Let's check it with the denominators. If I plug negative 10 into either denominator, what's my denominator going to be? Negative 3, something that exists. What? If I plug in negative 10 into my denominator only, it gives me a value that's not 0, right?
Right.
That's one of the ways that you can check to make sure that you got the right solution if you don't want to plug negative 10 in for every x to make sure the left side equals the right side.
So just as long, it can be any number, just as long as it's not 0 and it's right.
Oh.
This next one, it's always nice when the denominators are the same, right?
Yeah.
What's the lowest common denominator?
Minus 8.
So that means I'm going to multiply every single term by x minus 8. When I multiply the first term by x minus 8, what's going to happen? Cancels out. But for the second one, it's not. It's just going to end up getting multiplied through. And then for the last right side, cancels out. So again, every single term. Those cancel, so do those. So this gives me a negative 2 plus, what's x times x?
X squared.
Then this gives me a negative 8x. And good old quadratic. Good old quadratic. Okay? Get everything to one side and see if you can factor. Go ahead and do that. Me personally, I like to keep my x squared term positive anytime I factor. Because anytime the x squared term is negative, it's basically there's an a in front. Then you got to slide, divide, bottoms up, and that's keep it positive. Keep it positive. So I'm going to go ahead and subtract the 7 over. And this gives me a negative 9. What are the two numbers? So when I set both of them equal to 0, I'll get x equals positive 9. Do they both work?
Yes.
Yes, they do. Questions on the whole multiplying by the lowest common denominator? The last type, you need to factor your denominators before you actually multiply, okay? So, here's one example, okay? Very similar to the ones from like the first flap, because you have one fraction equaling another fraction, but I want to show you using this other particular method, okay? How does x squared minus 4 factor down to be? So for this particular skill, which you'll definitely need it for B, the last one, you want to multiply by the lowest common denominator, okay? The lowest common denominator in these cases is basically basically like what they have in common, right? So this denominator has an x plus 2 and an x minus 2, right? This one only has an x plus 2. But in order for it to be a common denominator, they both have to have the exact same thing. Whoa, there's like 3 different people that said something. What would be my lowest common denominator here?
X plus 1.
X plus 2, because they both have it, but then an x minus 2, because the one on the left has it, but the one on the right doesn't. Okay? If you only had the x plus 2, then you're forgetting about the fact that this one also had an x minus 2 with it. So you have to take into account what they both have in common, or what they both need. So yes, you will want to multiply basically both sides by your lowest common denominator just like before. So here, when I multiply the left side by x plus 2, x minus 2, and then this one by x plus 2, x minus 2, on the left, both of these would cancel out because that's what the denominator factored down to be. But over here, the x plus 2 would cancel out, and you'll still be left with an x minus 2. So x plus 6 equals 3x minus 2. I felt like I explained that really badly. I'm so sorry. I'm running back through it in my head.
You just cross out the one that's the same, and then multiply the numerator of the other one for the one that is.
So basically, whichever part doesn't have that lowest common denominator, that's what you're multiplying by. So then this becomes x plus 6 equals 3x minus 6. Be careful. Subtract x. I would subtract x. What's 3x minus x? And then I'm going to add 6. What's 6 plus 6? So x is equal to 6. Does it work?
You have to check them for both.
Yes. Yeah, you want to make sure you check for both.
Do you check the original or the LCD?
You can go back to the original. Go back to the original. Yep. Question? No, you can. I'll just show them the other way too. So yes, you can check it still with the denominators, or you can always plug it back into the whole original. It still works, as you can see. Like if I just plug it into the denominator, that would be 32, and the other one would be 8. Since they're both not 0, then you're good. All right. Let's look at this one. Can I factor the bottoms? The one on the right. What two numbers multiply to give you 27 that add to give you 12? So since that denominator multiplies the factors to be x plus 3 and x plus 9, and I look on my left side and I see that I only have one denominator on the left side, which is an x plus 3, what is my lowest common denominator? X plus 9 and x plus 3. Which means that every single piece is going to get multiplied by an x plus 9 and an x plus 3. Whew. Now on my key, I don't write out that step. I just know that, okay, I know what I need to multiply. So like in this first part, I'm only going to multiply that 1 by a what? An x plus 9, because the x plus 3 cancels out. For the second piece on the left-hand side, I'm going to have to multiply that 2. Yeah, there was a 2 there. So whatever was already in the numerator is going to get multiplied by that common denominator. What happened? What's wrong?
Oh, no, you're good.
What happens on the right side? Cancels out. That x plus 3, that x plus 9 cancels out because that's what the denominator was. So then I'm just left with x squared minus 3. Questions on that whole multiplying by the LCD, lowest common denominator, when they're not the same? All right. Can you guys go ahead and work this out? Give me my solutions. So the quadratic you should have been factoring was x squared plus 25x plus 66. What two numbers multiply to give you 66 that add to give you 25?
3 and 22.
3 and 22. That's why I was saying don't overthink that those two numbers, okay? 3 and 22, when you add them together, they give you 25. So you get x equals negative 3 and x equals negative 22. Do they both work?
No.
Which one does not work?
Negative 3.
Negative 3 does not work because if you plug negative 3 in here or even here, you're going to get 0 in the denominator. And you cannot divide by 0, so your only solution is negative 22. Okay? Always make sure you check. Now you can have 0 in the numerator over a number, but you cannot have 0 in the denominator. Questions on solving rational equations?